Right, so you've all had a chance to have a look at the code. There are 4 main classes, and generally in Python, because we're all doing Python, we are gonna start with a method called main, and that's where like the bootstrap for Python is. You start from the code from, and that's executing right at the bottom here. Okay. Remember, Python is an interpreter, so sequence does matter for Python. Okay, so the first method we've got is the main. Main method is outside the 4 classes that we've determined. And the 4 classes we have is puzzle, which is the longest of all, has pretty much everything. Then we've got the pattern class. And then we've got a cell class and a block cell class. Can anyone tell what's this after the block cell?
Hello. Hey. Yeah.
I will see you there, I think.
Okay.
Hello?
Yeah. So this is, can anybody tell?
Inheritance?
Inheritance, yes. So there's only one inheritance in our existing code, and you might be asked to, or as part of practice you might have already done, inherit from the cell class or inherit from the pattern class. And we all know, hopefully, what inheritance does. You've got all the functionality of the cell class plus this. Okay. So there's, as you could see, there's some missing bits in the code. There's an update cell function here, method here, which is just pass. Everybody knows what pass means? I assume yes. If you don't know, then just stop me.
I don't know.
Okay, so pass, who's going to tell us? Who's going to tell us what does pass mean?
It sort of means if that function's run, there's nothing to execute, so just keep on going from that point because there's nothing to return or do.
Yeah,
There's like
okay,
no
that's good.
functionality.
Okay.
Absolutely. Yeah.
Okay.
So why is needed in Python and not in C# or C++ is because we don't have the brackets or anything in Python. And if you just remove it, then Python would expect some definition of the previous method. And this can apply to any block of code. You have got an if statement inside. If you don't want to put anything right now, maybe sometime later, you just say pass. So pass is like do nothing, as I don't know who it was, Warren or maybe, but it does nothing, but just a placeholder that this is a line of code at this indent. This is the reason why we need pass here in Python. If it was C++, C#, you just do with the empty brackets or something. Okay, great. Right. So let's begin at the start. The main function is outside the 4 classes, as we said. And the purpose of the main function is just to interact with the user, ask them if they're loading a puzzle from file or have a standard puzzle. A standard puzzle is a random puzzle, randomly generated, and a non-standard puzzle is coming from the file. The file name will be provided. Notice there is a slight validation on the file name. So if the file name is greater than 0, the length, then the file name will be passed to the puzzle class in the init function. So puzzle class, when we create an object of a class, its init function is called the initializer or the constructor. Okay. And if the file name is passed, the .txt will automatically be added to it. It wouldn't be required. So if you write puzzle1.txt, it wouldn't load because it's going to always add the .txt to it. Okay, so this brings us with the file names, file loading, etc. So if there's file name that has been provided, it's going to call another function in the init, which will go in the next 2 minutes. And that's going to load the puzzle from a file. If it's not, then the blank file name. If you don't say file name, then it's going to be a 8 by 8 puzzle with about 39 or 38 or so attempts. How do we know? Do we know what's being passed here? What's the first argument?
The
Is that
grid
grid size?
size.
Grid size. So it's always going to be a square. So that means it's 8 by 8. That means 64 cells. Okay. And what's this second argument?
Symbols left.
Symbols left. And this percent, sorry, times 0.6, that means 60% of 8 by 8. So it's all hard-coded. Usually good idea to change it. But remember, this code is not the best way of writing the code. So intentionally, they've written code in a non-conventional erroneous way. There's issues with the code, which one of them or two of them, they might ask you to fix while in your exam. Okay, so that's what we can have a look at as well. Right, so that's your main function. The whole purpose of that is just the main function is going to load a file or do a random puzzle. After that, it is running in a loop. So that means once your game is ended, it will get you the score, print the score, and then ask you again, do you want another puzzle or not? Right? So it's going to run in a loop. Okay. Can we think of any issues with this particular function? What sort of errors can we face in this function?
You need to validate file name entry. So I could literally just enter about 10 spaces and it'll still come up and it'll still try to like find the file even though it might not exist.
Okay, yeah. Anything else? Okay. So that's good. That file name validation. Okay, that something could be done here, something could be done maybe elsewhere as well. Okay, that's fine. What about the number of arguments? Are you comfortable with how these arguments are being passed into this star ARGS? Who's not comfortable with this? So you're all okay with it. That's good. Right. So if you got one argument, then obviously it's object-oriented. So self is always going to get passed to everybody knows self. Yes or no? Yeah. Okay. Thumbs up means yes. Okay. So self is always going to be there. Don't forget it. Right. So that's the second method. Naturally, in terms of flow, we get into the second method. And this is a slightly lengthy one here. Okay, what happens in it? So there's two ways we could enter this method, either with a file name or with two arguments, two numbers, right? So if the first thing it checks if, so this code is slightly modified. I forgot that I've slightly modified this code for solving a little problem. So I'll get back to it. So there's usually an else here in the original code. So if there is one argument, that means you've been given a file name. If there is more than one argument, this will be usually else statement. So you'll go into the second portion of the code. The second portion of this code allows you to initiate a fairly blank puzzle, randomly generated at times. And the first part is going to load it from the file. So let's have a look at the load puzzle function first. So you'd notice that there's three variables that have been initialized, and then three of them are lists. Usually, if you don't want to initialize one of these variables in here, you could do it later. It wouldn't make much of a difference. But if you're using a grid or a list, then it'll be useful to initialize them. So grid or list must be initialized before you use it. Okay, so in load puzzle, let's have a look at load puzzle because this is something that might come up. I feel like it's the most likely one of all others. Because there is a bit of error validation as we've raised that there's a file name. What if the file's not found? What if the text format inside the file is slightly different to what we're expecting? So all of that needs to be validated. Okay. At the moment, so the only validation that the file does, this load function does, is it tries to load it, and if it fails, it just catches the error. So this is a slightly modified code. Apologies for that, but this code already handles slight changes here. That these are the changes that would handle the exception. So if for whatever reason the file is not able to load, this particular function returns a true or a false. True means it has been loaded, false means it's not been loaded. This is slightly different from your vanilla or original code, right? That's because one of the zigzag questions, the simplest ones, so it might be a 4-mark question, required us to modify this method so that it returns a true or a false. And so that even if there is no file that's been, or the file loading failed, we would still be able to play the normal randomly generated puzzle. Okay, this is one of the zigzag questions. Has anyone tried the zigzag questions first?
Yeah, I've done a couple of
Yeah.
them.
Okay, good. So this was one of their questions. So I was working with somebody and forgot to get the original code back. So this is what you do. Basically, you return a true or a false at the end of a function if the function is successful. So who knows what the try and except does here? Who's going to tell us?
With the try, the block of code inside it try for better wording. It tries to run the block of code inside that inside the indented with it, and then if something happens, like let's say there's like some sort of error that you want to happen, if something happens, then you run it in the except.
Okay, almost there. Very good. Right. So the purpose of try except, and this is something that you might face in your 20-minute quick coding part as well. And generally, it's good to know. There's two ways you normally handle validation. One of them is using if-else statement, if this happens, or if this is a digit, or if it is greater than something or less than something, or if length is greater than 0 or something. The other way you could do is try and except. So when you write code in try and except, as rightly discussed now, whatever is in the try block, Python will attempt or try to run it. If there is an error that will crash the code inside the try block, Python will simply stop running and go to the except block. It will not crash the code. Okay. So that's the benefit of a try except. If you're expecting a specific type of error, you would handle it in either a try except. It kind of saves us time writing conditions for exception. So if you were to write the same code in an if-else statement, you'd have to write a lot of if-else, else, and so on. Whereas with the tries, you can have one or more except blocks at the end of the code. And regardless of where in the code you fail inside the try block, you can fail in the first line, you can fail somewhere here. Regardless of where you fail, you will go to the except class. Sorry, except block of code. The downside of it is that you actually usually don't really know how much you've executed. So if you run this much and certainly you've faced an error, all of a sudden you go to the except, whatever is done is done. So the purpose of the except block is to recover from that error. So usually you would write try except blocks with a certain type of exception or error, like file not found error or something like that, index out of bound error. But the code here uses just the except, and that's usually called the bare except, which is normally discouraged, but it's there, so it's going to use it. And because of this, in your normal code, if you try to give it an incorrect file name, the code will not crash, but it will not do anything useful either. It will just go in a limbo state. Okay. So if I try to run this code, I don't remember what the state of the code is. But if I give it an incorrect name, so ABC, now it's giving me an index tuple or index out of range error. So this is some sort of error that's coming up, which you will not get in your normal vanilla code. Okay. And that's because I've done some changes here. In the normal code, there is possibly, I think there's just a pass here. So that means do nothing. Okay. So if you were in an exam, you get a question that says, just like zigzag, if user enters an incorrect file name, you need to fall back on a random puzzle. In that case, you would simply go except block, return false, otherwise return true. And in your init function, go back to your init function. If file is loaded successfully, then you don't need to go in the second block, which is random. If it's not loaded successfully, then you have to initialize it. Okay. So we saw an error, so I'll quickly fix it by just giving a new tuple. That was the error, say 38 or so. And that's probably going to help us run it. So if I say ABC now, it's going to do a random puzzle, just like we expect a random puzzle to begin. But if I give it a file name, then it will give us puzzle. Where it's gone? It's hidden behind my zoom controls. Sorry. Right. So puzzle one just loads as normal. So I wanted to do it a little bit later, but somehow I'd already implemented this change in the copied the wrong version of the code. Hopefully there's no other solutions already in there. Okay, so that's the load function. Are you okay with the load function generally? Who wants me to go into the load function? Okay, nobody. Okay, great. Do you know what the width keyword does? Who knows what the width keyword does? Right, okay. So width function is basically just a declaration of your variable f. With this is how you've declared it. But width function basically says when you're done with this variable at the end of the block, I need to free it up. So normally when you open a file, you have to close it. But if you do it with a width keyword, width would ensure that when this block ends, and regardless of successful or unsuccessful, even if there's an error, width will make sure that when you exit this block, the variable f would be freed up. It will be closed properly. So it will close the connection for you. And you could do it with network connections. We could do it with anything really. Usually do with things where you have to free up the space or release the connection or release the lock after you've used it. Right? Okay, going back to our init function. That's our main init function. This has some hidden information here, which is how our patterns are formed. Who wants me to go into the patterns? How is it patterns created? How is it representing a 3 by 3 9 cells. So just briefly, this is in a spiral. It's a 3 by 3 block, left top, going right, down, left, top, and middle. That's how it's being checked. And if you're required to create a new pattern, that's how you would do it. You just create a new pattern. The pattern string will be defined here, and you'd append it to the symbols that this new symbol will be available for validation. Okay, and you append the pattern in the list of all allowed patterns. Okay, what happens after we've initialized? We attempt the puzzle, and that's control going back to the main function, and that's where it's saying whatever puzzle you've created, attempt the puzzle. So when we attempt the puzzle, where do we go? This is your main game loop. Okay, so as long as you're running inside this game loop, you're going to continue. There's no other way of exiting. Right. So you got to, how are you going to get out of it? You got to run out of symbols for you to come out of it. So if you've got 0 symbols left, that's when it says finish equals to true. That means at that point you return back to the calling function, which is the main function outside. And as we already seen, main function is going to ask, do you want to play another game or not? And if you say yes, it's going to take you at the start. If you say no, it's going to exit. Okay. So there's a bit of logic right in here. Some of them are validated, some is not. So you'd see again, there's use of that try, except, and a pass. Okay, so that basically means try to do this. If there's an error, do nothing. And all that is done inside a while loop. This is quite nice to see that this sort of functionality you can also use in your 20 minutes programming exercise, which is often going to require you to do some sort of validation. So go in a while loop in an invalid state and keep you asking for user for input until you reach the correct state. Okay. Right. So this here is where we ask for row number, column number, both in a similar format, and then we're asking the user for a symbol. It's again another input, but it's just being asked for in a separate method. Okay. So how do we do? Once we've got the symbol, now in any case, we've reduced the symbols left. Now, even if it's an invalid symbol or whatever it is, just as long as we're able to enter a symbol, the next line is just, you lose a turn. So this is something that we need to think about if we want to do some sort of validation that, you only lose a turn if you've played a valid symbol. In that case, just remember it's here that you're reducing your remaining symbols. You can move it around so that you don't lose a turn until you've placed a valid symbol, right? Okay, so this here, next one is a bit more of a logic form. There is a GetCell method, and behind that, it's hiding that mapping from row column to one-dimensional list of which is called grid list of cells. Okay. Now this is crucial. So if you don't already know how that's working out, I would recommend either looking at one of the online resources or just raise your voice now. We can go into it. The GetCell method. So that's basically saying behind the scenes, there is a one-dimensional list, and there's a lot of calculations that's going on, usually just a simple formula, but only once you get the hang of it, which is going to translate the rows and columns into the index that you need to get to in a one-dimensional list. Everybody comfortable with that? Right, once we've got the cell, now that cell is represented by one location in your grid and an object in your list in a 1D grid. So once you got that cell, then you can do all sort of method calling on the cell. So you basically then say check if the symbol that's been passed to you, is that allowed? If it is allowed, then you say change the symbol in the cell. So you replace the symbol, and that's probably the best position where that symbol's left should move to if you were to ensure that you only reduce the symbol's left once the symbol has been used. Okay, so after that, we do the check for match pattern. So this is, again, one of the really core and the most confusing and in-depth method, check for match with pattern. And this gives you a row and column. You've been given row and column. Well, we can check it all around the puzzle. If we were supposed to, just check, we could just simply check the whole puzzle. Why is it that we're given a specific row and column? Can anybody tell?
Sorry, what was the question?
So why are we given a row and a column in the check for match with pattern? So we're checking where's the pattern, the newly added symbol, is that part of a new pattern or not? Why do we need the row and column for that?
Because
Why?
that's what it uses to map where it starts the algorithm from.
So why do we need to limit that mapping, so checking algorithm, why do we need to limit it to a specific range? Why not check the whole grid?
It reduces the amount of things it needs to check. Rather than checking the whole grid, it can just check every possible 3x3 around the cell you just placed.
Okay. Anybody else want to have a go? Why is it that we must check only that region? Why not the whole grid? I can tell you complexity or computational power is not the reason. There is no other way of marking an existing graded or scored pattern. So if you created a pattern somewhere else in the puzzle, there's no way of telling us other than this row and column that this new symbol or this existing pattern has that just been scored or was it scored the last time? And if you don't know if it was scored the last time, you might end up scoring it twice. Okay, so that's the reason why you have to only check the location where you've just placed the symbol. You will not check the whole grid. Is that okay? Okay. So once it's gone past, it gives you either 10 points or 0 points, something like that. Okay, so if it says there is a pattern that's matched, it'll give you 10 points, and then you add that to the total score. This kind of if is very much useless because if it's coming with a 0, you don't mind adding it, but that's okay. Okay. So you get a score back from the check function. That's your 10 points coming. So if somebody says change that score somewhere, so all you have to do is somewhere in the check function, you change the score according to the requirement. Okay. And then if the last bit is if the symbol left, if you run out of symbols, then you exit. So that's your main game method. A couple of important other things. There's a display puzzle method, which is reasonably straightforward. Let's quickly go to that before you go to the other ones. And all it does is there's a slight bit of trickery here that if the grid size is less than 10, so you'd still be able to play games that are bigger than 10. If the grid size is less than 10, you just wouldn't see the printing of the row and column here. And the reason is at the row is fine, but if you write the column, then the printing goes all over the place because the column number would be more than one digit. So it will just disturb your column numbers and the grid printing. So that's what they've done is if the grid size is between 0 and 10, then include the index of that list, so of the row and column. If it's greater than 10, just don't show the numbers at the top and on the side. Otherwise everything else is okay. Okay, printing wise is quite straightforward. Okay, what else is important? Okay, so let's quickly go to the pattern class. So the pattern is basically storing a couple of things. And in one of the other questions, you might actually be able to see later on that we can add to these bits of information regarding the pattern. Because it's object-oriented, everything to do with the pattern is useful to have put everything inside this pattern class. Okay, so if this is to do with matches pattern, put it inside here because it's to do with the pattern. And there might be new functions that they might ask you to create within the pattern class. Okay. What does the get pattern sequence does is simple getter. You set it here at the pattern sequence and you get it right here. Whenever you need it as an object-oriented language. Even the Python, you can access things from anywhere, but as a convention, it's a private variable you want to get through a getting method. So you might be asked to write a couple more getting methods for a specific functionality, so don't worry about that. Just remember the self needs to be there. Okay, object-oriented Python, self needs to be there. Okay, then we've got two cell classes. One of them is the plain cell class, simple cell. It just tells you what's already in the symbol, which symbol is there in the cell, usually blank, initially blank, and then which symbols are not allowed in that cell. Okay, and there was a little discussion on the boards as forum as well on about this. And the reason why there's symbols not allowed is mainly because you want to limit the same symbol in a 3x3 grid. You don't want the same symbol to be added once a pattern has been formed. So if there is a X pattern that's been created, you don't want the remaining 4 empty cells to get another X, because using that you might end up creating a lot more X's than there are 3x3 spaces. So just a complication in the game. There's some location within the pattern matching that this is being populated. So this is being called somewhere. We'll have, if time allows, we'll have a chance to have a look at that. Okay, there's a fair few methods here that we possibly need in some cases. Mostly straightforward. There's a change symbol. Basically, it's a setter. You set a value in it, give it a new symbol, it will just set it. And then there's a get. Update cell does nothing at the moment, but you might end up as part of a task. So this does not necessarily mean that there will be a task to deal with it. Okay, there's a chance that they might say do this, or there's a chance they might ask you to implement it in the block cell class. Okay, so the two possibilities: you might be asked to do it here or in the inherited class. Okay, so leading on to the block cell, which is inheriting from the cell class, which means all the functionality of the cell class plus the @ symbol. Initially, the symbol will be given to you. So this is already the symbol. Anything here @, you shouldn't be able to put any symbol of your own because it's blocked. Okay. Check symbol allowed is always returning false. This is an overloaded method. As you could see, check symbol allowed is in the main symbol in the cell class as well. So all it does is overrides and says it's always going to be false. So no symbol is allowed in that one, right? Right, that's good to know that most of it, especially the GetCell method, you understand that. And I kind of did a little print statement here to say what row column goes to which index. And while we're here, we'll have a look at when the grid is going from 8 row number 8, column number 1. That's your first cell in the grid. So the grid is going this way and then down and so on. So this is basically adjusting for that. Just a mathematical formula. You could use it here. Same formula, you could use it wherever you want. Okay. So check for match pattern. Very well said by Varun. You could see that it's running from, so it's got a 3x3 window. You could say that's going to scan over the specific cell that you've just added. You've just modified it. The window is only going to scan those 9 possible locations where that new cell, the new change cell, is part of the window. If you go beyond it, that means you might end up rescoring one of the existing scored 3x3 patterns. So you could see that this here, the first method, again, it's in a try. And you could see there's already a nested loop. There's a 4 and a 4, 2 nested loops. And there's another 4 inside it. And then there's an if p dot matches pattern is going to take us somewhere else. And there's another loop inside it. So there's a lot of loops going on. So this computation is not an issue. Okay. I'll come back to your question at the end. Right. So there's a lot of loops going on here. And then there's a return 10. Okay, so 10 is where you get 10 points. But the problem is within the except class, there's nothing happening. Again, this was probably a pass which I changed it to exception code for being index out of list. That's because there was an exception that was happening when index goes out of the list, but we don't raise an exception. So one of the reasons why you still use a try except is that you expect you expect the code to fail in a specific way, and you think that's okay, and you want to get to the next iteration. That's perfectly fine. So you can have a try except. If it fails, just don't do anything, go to the next iteration. So only if all of that code in this method successfully runs, only then you reach the return 10. Okay. If you match it and everything's happened, then you return 10. Otherwise, you go and return 0. So all the other exceptions are going to get handled with the try except. And some of those are exceptions that you might need. So might be asked for you to, might be useful for you in your exam or in some of the problems regarding the pattern matching to modify that a little bit. Okay, some of the exceptions might be handled differently. Okay, but for now, that's all it does. All the exceptions are masked if it goes beyond the index. So for that 3x3 window, if you're going too far to the left or too far to the top, it wouldn't give you an error, which it usually should give you, which is index out of bounds. It wouldn't give you that because of that except. So I just wrote print here so that even though it's still going to let you do that, let you continue with the program, it just says exception, there's a problem with the code. Okay. Again, just making it a little bit more verbose. Okay. Right. So we know that this is going from left to right, top to bottom. So rows first and column first. So for each of these 3x3 window, what is it doing? It's creating that pattern here. And it's creating that pattern in the same sequence, in the spiral sequence that your original pattern, which you're going to match, the master pattern is written in. Okay, so the master pattern is written in that spiral. So this is also creating that spiral form. Once it has got that spiral in a pattern string, at the end here, you got the pattern string. Notice this is 9 cells. And you could check that this is going from row column and then row column plus 1, shifting to the right, row column plus 2, shifting to the right more, and then going down, down, left, left, up, right. So that's going to make a pattern. So you're basically creating that pattern string, the 9-character long pattern string. Once you've created that pattern string, you can simply match it with the existing pattern strings we created in the init function. So those 3 pattern strings, or you might be asked to add a new pattern. If you got those, if it's matching with one of those, then you could simply say pattern matched, correct, go on. But what's happening here? You got the string up till here. There's another for loop. And this for loop is for all the patterns that are available. So this is not going to do 9 times. It's only at the current level, it's only going to run 3 times, right? Why 3 times? Because there's 3 patterns there. If you were to add a 4th pattern, say C pattern or something else, it would run 4 times. Okay. Now, more importantly, it also, you've got the current symbol here as well. It also matches with only the current symbol. So even though the method p.matches pattern is going to get called on every pattern, that method itself will only check the contents of the string if the symbol you've just added is the same as that pattern's symbol. Does that make sense? So if you've just added a Q and this out of those 3 you're checking the Q pattern, that's okay. But the other 2, the X pattern and the T pattern, you don't need to check those. So even though the method does get called, it will not check it. It will just simply say, oh, that's not matching. That's not the current newly added symbol, so we don't need to match it. Okay. So only if the same symbol is being, the same symbol to what you've just added, if that's the symbol in the loop that you're checking, only then you will go through with the rest of the matches pattern, and that's inside it. We'll go there. So once you get a true or a false from p.matches pattern, that means a pattern string that you've been given, if that matches exactly with what is available in the init function, that means you have matched a pattern. If it doesn't match, that means you haven't matched the pattern, so you don't go in this if. This if is only the success story, so that's why at the end it returns 10. If you don't match the pattern, after all the 3 by 3 swapping around and checking, then you return 0. So if you have matched, if you're going to go into match pattern, if you have matched the pattern, then what will you do? These are 9 rows again. Notice this repetition 9, which means there's something to do with that 3 by 3 window that you're checking. And it's again going in the same sequence, even though in this case, sequence does not matter. And that's where it's saying add to not allowed symbols. So current symbol is not allowed if you've matched the pattern. All 9 cells will say don't allow the same symbol in here again. 5 of them would already be that symbol, so that's meaningless. But around 4 of them would not have anything in them. So you can't have the same symbol in those 4 cells either. Okay. Great. So that leaves us with one little thing here, which is called the match pattern. Now, this is very well written in the sense that it's object-oriented. It's to do with, it's a pattern's property. So it's the pattern's, the location for the code is ideal for to be put inside the pattern class. Okay, so pattern's going to tell you, this is a string that's been passed on to you. Does it match with me? Yes or no? So let's see. What is the definition of this method? Where is it? Here we go. Matches pattern. So not only does it take the pattern string that is in passed, it also takes the symbol that's been placed. Okay. And the first thing we check is if the symbol we've placed is the symbol of the pattern, then go ahead. If it's not the same symbol, then just simply say return false. We can't match it. Okay. So you're not going to check the pattern matches for a different symbol. You've placed an X, you're only going to check for X. Okay, that simplifies our lives. Okay, so then there is there's a little loop here. Again, there's something that I've just added in my code. Should have gone with the vanilla code, but tiny verbosity. I like to do this because that means whenever it's going to break, it's going to still give me a little printout, even though it's not going to break the code. It just tells me that something's happened here, right? And so this is basically, what is this doing here? There's a try. And for count, where's that count coming from? Okay, so as you might remember, there's a 3 by 3, which means 9 characters long. We're only matching 2 strings. Forget about all the 3 by 3, etc. Okay, so this pattern, there's a string which is 9 characters long, and there's another string which is also 9 characters long. One string is coming from the initialization of the pattern. The other string is coming from the pattern matching function that's just been being matched. So the comparison between the two is going to take place in this method. So we must see what is the nature of that string, what's inside that string. So notice that there's a QQ star star Q. So we've got Qs, even though the Qs might be in the correct position, but the stars might not be there. Because what is the current content of these dashes, the empty cells? It's nothing, it's empty. So the string you're matching might not be the string that is in the pattern. So you're not matching QQ star star Q star star QQ. You're actually matching QQ blank blank Q blank blank QQ. Okay. But how do we implement that? Whatever is in the star star is meaningless. How do we make sure? And that's how this particular method is working. So back here, what it's checking is 0 till the length of the string. Now remember, we're just working on 2 strings. Just try if the symbol that we've just added, if that location is the symbol, okay, is that right? That index is the symbol. And so symbol in where? In the symbol that's in the string that we've just been passed to check. Okay. So this must not be anything else. So if we are checking, there must be an X there. Okay. So if you're checking for an X, and there is an X in your actual original pattern as well, that will match on both grounds. So it will say there's an X, but if it says pattern string count is not equal to symbol, that means that is in the pattern string, that's not the X, then we'll return false. So you'd notice that we're kind of negatively ruling things out instead of matching, instead of positively counting them. So we're kind of starting from a match state, and for every character, all 9 of these characters, every single character, we're going to do 2 checks. We're going to check if the symbol that's been passed on to us in the string that we're checking, if that is matching with the symbol that there is, X, for example. And the second thing we're checking is that if in the string that has been passed to us, if that X is not the symbol, in that case, we return false. It's not a match. So that means even at a single mismatch, if we have got a single mismatch, we will return false. If we got all matches, then only we will return true. Is that okay? Any feedback? Let me check the chat. Right, okay. So I will repeat it once more just to be less detailed, okay? And possibly, so this is a double check. That's why it is checking for two things. It's making sure that, so you notice that this pattern sequence is from within the main pattern itself. Okay, so it's checking if the pattern that is there, you only check if it's an X. If it's a star, then don't go ahead. Okay. I'm going to annotate in this case. So let's say we've got an X pattern, which is X star, X star, X star, X star, X. That's your pattern, right? And you are matching with another input, and your input is, and this input is coming from, scrolling around that 3x3 window, and you're trying to match it with, say, X @ X blank, blank, I'm going to do this, X blank X blank X, something like that. Okay, so there's a block cell and so on. So you're trying to match those two strings. They should match, right? But if you were to match every symbol of them, they will not match because one of them is @ and the other, there's three of them that are blank. Whereas in the matching pattern that you have to match, master pattern, all of those are stars. So what this code says here, so this bit of the code says, we're going to rule out one thing at a time. So it says, first thing, check if the first location is something that's worthy of checking. Is it an X? This says, yes, it is an X. The second part of this and says, check the pattern we're checking here. Now, if that is not an X, we're going to return false, which means check fails. But if it isn't, if it is an X or anything other than X, well, naturally it's just an X that we're checking. So if it is an X, then you will not go in this if statement, which means you will not return true, but you will go to the next count. That means you will go to the next count here. You'll check the second character now. What happens with the second character? The first thing we are checking is in the master pattern. Is this the symbol that we were checking? Is this an X? It's not an X. So we don't even go to the next part of the AND. We just say it's not an X. We cannot go inside and return false. So we don't return false. We just go to the next iteration, third character. It's an X. We check for the matching X in the other string. Matches, we can't return false. Then next one, we check. It's a star. It's not an X. We don't go any further. We say go into the next character. So now you can see the pattern emerging. We will only check if the master string, master pattern, has a X in the location in that string. If it's not an X, we won't even check with the string that has been passed to us. We only check if it's, so if this was, for example, T, the last one, we will, and we've reached this point, we will check if this last ninth location, is it worthy of checking? It says, yes, it is an X, so we must check. And then we check here. If this is not X, and this is what it's saying, pattern string 9th location is not equals to X, in that case, we will be able to go inside this if statement and return a false. That means overall, we'll say, we reached to the 9th character, but pattern does not match. Return false. Okay. So what does that mean in both cases? Now we've seen match and not match. We go back to the pattern matching method here. This is where it's being called. So that simply says if it's a match, if it returns true, then we will return 10 points and do a little bit of housekeeping and don't allow it to be added in the 3x3. If it's not a match, what happens if it's not a match? We don't go inside it, but that doesn't mean we exit. That means we go here and go to the next for loop here. And if that's done, then we go to the next column. If that's all of 3 of them, then we go to the next row. Okay, so that shows you that the first time that the pattern matches, we return. We don't do any more checking. Right, so we've kind of gone in quite depth of the pattern checking function. Who understands? Okay, couple of questions here. Purpose of the exception in 231. Let's go to 231. Yeah, so this is an exception. Usually this would be set as a pass as well, but I just printed it anyway to see what's happening here. So the purpose of this exception is to check if you are gone beyond. So you just try that. Okay, if your symbol sequence, if in your pattern sequence that you've got is not 9 characters, for example. But you're right in saying, well, when will it be checked? Okay, so it would only happen if there's something wrong here, and the only thing that could be wrong here is you could go out of bounds, right? Okay, so there's no major purpose other than that I could say. Anybody else could see a purpose here for this exception? Okay. Right. Okay. So can't see any other objections. So this is where I normally print it where this is in the try, and only reason here would be where it goes out of bounds. And normally that would not occur because it does a range on pattern sequence. So it does on a self-taught pattern sequence. So that means if the patterns that have been passed on to you is less than 9, and that's ideally already going to raise an exception in the previous method. So I've not faced this exception before. Okay. And going back to the chat. Okay, how does it know which pattern it's checking against? So that happens in this method here. So we see that first loop is for the rows, second loop is for the columns. So now row and column, you've got one specific cell we are talking about. So all this is about that particular cell. And so which symbol are we checking for? Here is it. So you're checking for all patterns. So P in allowed patterns, that means you're checking for all available patterns. You've got 3 patterns. It will run, this loop will run once for every pattern, but it will pass on the current symbol. And current symbol you just get from the current cell that has been given to you. You just see what's the newly added symbol you've added to it. And you pass that current symbol here. And we just saw that when we go in the matches pattern, so the method is being called for all patterns. All 3 patterns, the method will be called. But it won't go beyond the first line. Let's have a look. It won't go beyond this line unless it is of the same symbol. So if you're checking X, only for X, we'll go here. For anything else, for a Q pattern, you will say, the symbol we just added is X. Symbol we've placed is X, but symbol for this pattern is Q. There's no chance it's going to be matched, so we just return false. Right? Okay, we could have done better ways. I'm sure they've got real programmers working there, but that's the job. They could have written the correct code, but this is part of your exam. So, okay, what object-oriented programming techniques are used in the program? So up till now, we've seen there's Not a lot, because Python is not an object-oriented language, and this is much simpler than the previous few years. We've just seen a bit of inheritance, encapsulation. We've just seen, we might see some overloading. There is a couple of functions that have been overloaded, and you might be asked to write more overloaded methods as well. Okay. You'd also see that grid there's a bit of polymorphic behavior there. Grid is of a cell class, so it doesn't come out very well in Python because you can have a list and put anything inside it. Whereas in C++, C Sharp, Java, for example, you would have to create a list of a specific type. So you'd have to create a list of cell type and then put different types of cells in it. And any cell that inherits from the cell class, for example, this block cell, that will still be okay to go inside that cell, inside that list. In Python, that's not even an issue. You could put anything inside a list. So Python kind of spoils their party a little bit. Okay. Any other questions? And we kind of covered the whole code now, from kind of start to finish. The only thing we've not have a look at is this. Does everybody understand what's in this file in puzzle 1? So somebody said we might need a save function. There is no save function, there's a load function. Yeah, so that's where I'm getting on to. We're going to go on to programming problems. There's a question you raised. When you make a pattern, you can still enter some letters in the empty gaps. How would you make it so you can't do this? Right, so if you want to make a change to your program so that you can't do anything in those empty gaps, we just saw where that's happening. That is your match function here, right here. So if the pattern matches, you're adding these 9 lines and you're adding the current symbol. So you can't add the current symbol. If you made an X pattern, you can't add more X's in those empty blocks. So if your problem requires you to not let anything else added here, you might add more here, or might be able to do it in a different way. But if nothing else needs to be changed, you can simply add more symbols here that don't add anything to this. Okay. Don't add an X, don't add a Z, don't add a Q, whatever symbols you've got, just add all of them here. And so this is where you're basically saying, do not allow that. Okay. Where is that actually being validated? When you get in the attempt puzzle class, you get a symbol. So we did not actually go into get symbol from user method. Okay. So that's where you're checking so you got a cell. Okay. So this is where you would be checking. You already got a cell, row and a column. That's where you're asking for a symbol. And you've got the symbol. It does check that it should be one of the allowed symbols for the game, but it doesn't check on that particular cell. So that's where you could add, and within the while loop, so that the user knows that they have to add a different symbol. That's where you could say, in this particular cell, how would you know which cell? You'd probably have to pass that self in this method. So in this particular cell, you cannot add this particular symbol because it's in the list of symbols not allowed. How do we check that? We just within the cell, there is a method for that. It says check symbol allowed. So you pass the symbol. If it's in there, in the not allowed symbols, it'll return a false. It's already been implemented. So you just simply say check symbol allowed. So you just have to pass the correct cell there. You could also do in the main function, in the attempt puzzle function, but then that you will kind of lose that attempt. So if you do it inside the get symbol from user method, you will be able to validate it, and you can ask the user for a different input value. If you don't, then you have to do, if you do it outside here somewhere, you might have to either put this in another separate validation here, or if you don't do another validation, you'll just be losing a symbol. You won't apply a symbol. You can't go on beyond and say that symbol's still going to go in. You can't change the symbol, right? Logic determines that if symbol's not allowed, don't allow it. Okay. So how do you deal with the grid wrapping around in check for match with pattern after the coordinates go off the grid? You don't, it's still working, isn't it, initially? If you enter 8, 1, it checks, but it doesn't give you an error. Why? Because there was a try catch there. So check for pattern, there's a try catch here. And try catch all the way down till here is handling for except. It might be passed for you, but exception code for index out of list. So you're going out of the grid based on that calculation. And based on that, the try code is breaking and this except is catching it. If you're going outside the grid, you don't need to check that location. Right? Okay, that's pretty much already done for you. Okay. Right, so let's go to so this problem that I pretty much already implemented. I didn't want to, but I've already implemented it. This problem that says if you're given a file name that does not exist. So what we've done here is that we go in the load puzzle with it within the try except if there's a file name that we don't have, there's an issue with loading, not just file name. If there's any type of file loading issues, for example, if I say puzzle 1, I can mess it up a little bit, say ABC. Instead of 10, it's got ABC here. So, and if I try to load puzzle 1 now, this is going to give me an error, right? It does give me an error, but it still loads. And that's, why is that? That's because we've kind of implemented that requirement. Notice that it did print puzzle not loaded. That's my exception handling. So normally that'll be a pass here, which would do nothing, and that'll leave you in a limbo state. So that means you have to return either true or a false to say success flag. So load function, try to load. If it successfully loads, return true. That means you'll reach the end of the code when it's successfully. You could put it here, or you could also put it here. You could move the return true here inside here as well. But if it goes to the exception, that means there's something wrong with the files. Either the expected type of integer wasn't there, the number of rows were incorrect, something incorrect, file name wasn't there, file was already open, whatever the problem is, because this is called a bare except, which means it's going to catch all possible exceptions. So in that case, it's going to return false. So this is usually a good idea to return a true or a false from your method to say successfully done something or not. And in this case, if it's returning false, what do? Here, we've got a false. We reinitialize the arguments to something acceptable. Why? Because initially arguments were file name. It wasn't the 8 by 8 and 38 or something given to us. It was just a file name given to us. So before going into the rest of the code, we reinitialize the arguments. I changed this from else to just an if, because this will be our not an alternative path, but a second option. So this path will be taken if the file is not loaded or initialized as not loaded. This was about a 4 or 5 mark question. Okay. Now, anybody wants me to do a save function? This is too obvious now, so it's unlikely to come though. Okay, so for the save function, firstly, you would probably be asked to find a location where you'd say, ask user to save this. Okay, so currently there's no allowance of saving that game. The user cannot select to save the game, right? So somewhere here uh, in the attempt method, where is the attempt method? Yeah. So here, somewhere here, we're gonna possibly here we could say add a new row here. Do you want to play the game or do you want to save the game? Right? So somewhere here we're gonna input it if user wants to save the game or attempt it. It'll be quite a tedious thing to, show that every step you want to do that. What I tried was just to add either row number or you want to save the game. Once you have that, let's implement a save method. So it will be the reverse of your load puzzle method. Okay. So let's say we will be given a file name, right? So just like here, load puzzle, we've given a file name. If you want to save, you will ask user for a file name, and then you say def save puzzle. Okay. And you'll be given self and file name. And how would you implement? Just exactly like that. Don't even need to use your mind for this particular bit. I'm just doing a password now. And with open, what do I open with? File name, which file name that's just been sent to me. And as F, something here. Who can tell me what's wrong with this statement in line 96? Writing into it, yes. So file name will be provided to me, but I have to, by default, I'm reading from it. By default, I'm not writing into it. So I have to say some parameter to say I'm going to write it. I'm going to open this file for writing. So when you open a file, you can open it for either reading, writing, or appending, etc. So if you open it for reading, you cannot write to it, which was this here. By default, it's going to open it as read. You cannot write to it. So if you want to write to it, you have to say W for writing. If you want to append to it, you have to say append A with an A. And the difference between append and write is that append wouldn't start from scratch. Write will get rid of whatever was previously in there and overwrite, start from scratch. Append would continue where you left last time, so the previous contents would stay. Okay. Right, so what do we need to write? So first line was number of symbols and second line was something like this. So I'm just going to copy it and then you'll probably repeat the same thing over and over again. So self is with you. You've got self, which is the puzzle itself, and that's got a lot of things that you have to write. So you state of the game. Number of symbols that are there are not saved in a variable. They are saved in, so all the symbols are saved in the list here. And how do we get that output? What do we print? It's the length of this list, right? That's the number of symbols. That's not being saved elsewhere. And you could see which of the variables are not being saved in the puzzle by saying this has got no self dot something. It's not self dot something, which means after the end of this method, it's just gonna go away. It's only being loaded so that you can run this loop that many times. The next 3 lines will be the next 3 symbols. Once that's done, no longer needed. So when you're writing this, you just have to print this line first, and then you in a loop. So for, let's say, x in self dot allowed symbols. You can continue printing something here. What is it that you want to print? Just want to print the symbol itself. Yeah. Okay, so how do we write? Where am I? Oh, yeah, save puzzle. Yeah, that's okay. So that's my length. So this is something, the first thing I need to print is the length. So I'd say f dot right. And is this enough? What's my mistake? If I continue doing this, who's going to tell me what mistake? You need to format it as a string, correct? How to do that? PR, is that okay? One of the ways. Still a mistake, but let's see if we can figure it out. So there's no logical error, no syntax error now, but there's a little bit of a logical error that you'll have to find out. Okay, then I'm just going to write X here, right? So that's the first 4 lines of the code. What's the problem in these first 4 lines? Yes, new line. Good, good. You guys are following it. Great. So you normally, how do you do it? I normally just have to write the \n separately. If you do it in a different way, let me know. Okay, so what's the next thing we need to output? And you'd see there's a pattern now. So for count range 1 patrons, then there's number of patrons that we've got. So how do we output that? Get rid of this code. I'm just going to paste it for my reference here. I need to output that. Where are the number of patrons? There is a self dot allowed patrons. And the length of it will determine how many patrons there are. And I just dot write. And again, I have to convert it into a string. Okay, that's 1. And then for each of those patrons, I have to print a couple of things. And for that, I might have to write another little get method. So so that's the number of lines. The next one is 4. Again, I can use X, and not a very good variable, but still. Allowed patrons, you don't get any marks for your selection of variables, I think. And for each of those patrons, so X dot, there's a couple of things that you've got. There is the first, you need to print 2 things. So you have to print, where's my patron class? There's a method called get patron sequence. That's something you have to print. What else do I have to print? Just having a look at the patron here, the symbol itself. And there is no method that says, even though I could just say it's big symbol, but it's a good idea to have. So again, when if you are going to be asked to create that, you probably would be asked to get symbol method as well. Okay. And you return self dot symbol. So you'd have to call the symbol, comma separated, get patron sequence. I'm going to copy it so that I don't have to come down again. You could see this is going to be time consuming, and it's not very technical, but it's a little bit technical. So if you end up doing this, this might as well be a 14-mark question. Okay, so first thing is get symbol. And that needs to go to f.write. Then you have a f.write a comma. Then you f.write x dot get pattern sequence, and then you f.write a backslash, and so on. So that's going to write a fair few lines. And then what do you have to do next? You've done these. This is giving you a grid size. All you have to do is print a grid size. And then for each cell, you're printing two things here, and that's going to run for 5 times 525 up till here, every single cell, whatever is inside the cell, and whatever is not allowed in the cell, 2 items, just get it and print it. That's my own concoction. These are the last 2 bits, which is going to give you the symbols left and the current score the other way around. How do we know? In the load puzzle, whatever is happening, we just want to reverse it. Okay, so score. So although here for each symbol, each cell, there's a decision being made which type of cell it is, blocked or normal. But when you're writing it, you just have to get its value, get it to string, and that's it. And then score. Just get it self.score, turn it to a string, symbols left, turn that to a string as well. And that's your file. Now you would need some sort of file, the ability for a user to say, write the file, and then you have to ask the file name, and that's going to go somewhere in the attempt file. So altogether, as you can see, there's quite a lot of work here. Not very technical, not the most technical at each step, but there is a lot of work. And one of the tasks would be quite huge. The creating the save puzzle function would be quite huge. And that's why I personally think, and normally I've not seen such huge tasks, which you'd end up spending about 5 to 7 minutes. So that's why I don't think that size of that task would possibly come in an exam. So unlikely, and it's kind of too obvious. Every time there's a function that is really, really obvious, and that never comes in the exam, but it's good to know how to do it. I'm assuming you'd be able to do the rest. It is following the same pattern for every single step here. And you don't need to close the connection because you've used a width. So that means whenever you get rid of the width, it is automatically going to close the connection. If you don't feel like using width, you could simply do a f equals to this as well. But then all the rest of your code need to be back indented once. And then at the end, you have to say f dot close. But this is not the best place for f dot close, right? F dot close needs to happen in somewhere in something called a finally. Because what happens if you crash here? You don't get to close the file. So that's going to be an issue. So that's why we don't wait till we get a chance to close the file. Just go with a with statement. Undo, and we'll get there. Okay. All right. Happy with the save method, even though I've not implemented it fully, but you could see the rest of it is repeat of the same thing. Okay. Right. So that's the 4 bits that we thought we'd do. We've got about 15 minutes or so. If there is anything specific now, you've had trouble doing something, you've got a question that you've tried to attempt. Let's push it. Let's try to do it here.
Sorry, can you hear me now?
I can, yes.
Hi. I was just thinking, what do you think is the significance of implementing the check for match with pattern as a spiral as opposed to a 2D array?
Significance is that they can test you in an exam. It's simple as that. Every time they do it in a last year as well as previous years, they have this mapping function. It just checks your mathematical ability and provides more chances of going out of the array. You have to add another function to get to that row cell. And it's kind of a repeat of the last year's. That's really and it said they're not limited to, it's not a poor developer. It's somebody who's intentionally created this for us, right?
Yeah, thank you.
Okay. There's no, in terms of space complexity, there's no extra space it's taking. Or if it was 2D, it wouldn't take any extra space. You'd probably still do an index -1 anyway, because your list would be 0 indexed, whereas your game is 1 indexed. Even though in this case it's much more complicated. The first row in your grid is row number 8.
Mhm.
All right. So could you explain how to solve the wrapping issue, where if you did part of the puzzle on the right-hand side and completed it on the left, it would still count as a valid solution in the check? A very good question, a very detailed one. I don't predict any questions, unfortunately. This is something I'm really bad at, predicting questions, because it is such a big options. It's not a multiple choice. Again, you know this whole code, you feel comfortable with it, with the code, and my advice would be to just follow the steps, follow each task, and make sure you're making the changes for each task within that task. So when you read a statement, you have to make sure that you're already understanding what needs to be done before you go into task 1. And once you go into task 1, then you just follow that particular task at once. Don't do any other changes elsewhere, and that really would lead you to the final solution the way they want you to do it. Okay, so going back to the wrapping around issue, that is right, because what it does is it takes you from, it's going to map you on a cell that is technically left of it in a 1D array, somewhere else in the 1D array, but in reality, it's the end of the grid. So what you can do is, instead of going from, so in the check here with the start row and start column, you can apply a little restriction on these. So if, for example, if I say here, if the start row is, say, less than, is greater than, is greater than 8, isn't it? It'll be greater than 8. So if it's greater than 8, then you just continue. You don't check it. Okay, right now it's going to try and check everything. And wherever it goes out of the index of the grid, 1D grid, that's where it will go index out of bound, and that will be gone. That will go here, index try except. Because in the grid, it's out of index only when it's at the top right corner or bottom left, sorry, top left corner or bottom right corner, somewhere there. If it's somewhere in the middle, only to the left or only to the right, then it's still okay. Right, okay, sorry, I didn't check that one. So it's still okay, but this is where you'd put a little check here. So the start row that you're checking must be within the range. So each row and each column together must be in the row in the range before you could get the cell. Okay. So GetCell function is something where you could implement it as well. But ideally, because you've got grid size everywhere, so ideally you could just simply do a continue here, a continue there. So check for if it's still within the range. So is a 3 by 3? So if it's left too much left, what will happen? It will go -1 or something. That's something we don't want. If it's too much to the right, it will go to 7. We don't want to go to 7 because that'll push the 7, 8, 9th one out of the window. So we don't want to go beyond 7, beyond 6. So stay within that 6. So we kind of bind our window from 1 till 6, not till 7 or 8.
No, as in the theory could be about exception handling. We had like a question on our mock in March, so similar to like what how the exception handling works and things like that. So I don't know, that was a guess.
Okay, all right, good, good. Yeah, so validation, exception handling. So exception, as we saw, that exception handling is being used for validation, right? So in many cases, it is a very good way of exception handling, and you could do something, especially when you're dealing with data type. So if you're able to get an int as well as character, so you instead of saving that input into a string and then checking if it's digits and then you convert it into an int, you can simply convert it into an int right from the input. And if it's not an int, it will create an exception and you could do a try catch for that. So you could just try catch, and within that, you're just checking that input. And if you go to catch, that means you know it's not the valid input. And this is done here. As an example, this is being done here. Okay, so you could see that you start with an invalid state and you try to get input from the row for the row. So if it's only way it will break is if it's not an integer. So if you pass in an integer, it will be okay. Which means if you pass, say, 20, it will still be okay, even though it should break. So when you're probably doing a 5 or 6 marks question, you would do a validation on this one, saying if this is not true, and that will be probably an if statement. So you could see if you're checking the range in an integer, you could just do if else. If you're checking the data type and you must have an integer, there's other ways of doing an if else as well, but you could simply throw in a try and except here. And if it's not an integer, it will break right here. It will go to accept and do nothing, which means it will not be validated. So it will go back to the while loop and ask for another in. You could simply print here a failure message as well. But yeah, one more thing, I don't know if you've already been told that when you've been asked to print something, or if you like to print things when you're writing code, extra bits to see what's going on, remember to remove that. Just make sure you're printing the exact things that you've been asked to print. Okay, so how would you implement a method that would change a normal cell to a block cell? Who's going to take that question?
In the GetCell method, there's a formula which gets the index in the 1D grid. So you can set, provided you have the row and column of the cell you want to change, you can sub it into the formula that you have in the GetCell method, and then set it equal to a new instance of the block cell class.
Okay, that's one way. Yeah, good. So the trouble was, how do we get to that cell index? So what we could do is get this formula to get to the index from row to cell, and then simply go grid that cell and so on. What about when you actually just do a get cell and you get that cell here somewhere? Let's say we're in the attempt puzzle method here somewhere. It says get cell. Okay, so we've got the cell right here, the current cell. Can we not just say current cell equals to block cell? That'd be okay as well, no?
Yeah.
That's because you get your references. So current cell is not the actual data in it, it's the reference that you get. So that's how Python passes those things. So you could simply replace it right there as well, which should be. Now, when the examiner is going to create questions, they are also going to think about Python versus C#, the questions are going to be the same, right? So Java, someone attempting in Java would have to do the same question. They have to make sure that your effort in both of those languages is similar. So Python's sneaky at a few things, so you could do something similar in many cases, whereas you might not be able to do those in C#, for example. Like for example, class, internal class level variables, the privacy of the variables and scope. So they have to ensure that one, they have to structure the question so that it's equal in difficulty for all languages. And two, they are also going to guide you to those specific methods. And once again, I cannot emphasize enough that once you got an idea of what the question is asking you, you must stick to the methods they have provided you. Task 4.1 says modify the constructor in the puzzle. So just make sure you are modifying only the constructor in the puzzle, nothing else, nothing outside it. Because if you do something outside it, it's not going to lead the way that you need to do the changes, and you paste the code that might not even be checked. Okay, so here it says modify the pattern class. So that means within the pattern class, you might do anything anywhere as long as it's within the pattern class. It's a tiny class. Okay. All right.
I think that's it. Thank you.
Okay, great. Take care very much, and all the best for your other exams as well as computing.
Thank you.
All right. Bye-bye, everybody.
Thank you.
All right. Take care. Bye.